Welcome to Constellations, the podcast from Kratos. My name is John Gilroy, and I'll be your moderator. Today's episode is a recording of the panel discussion I moderated at Satellite 2025 in downtown Washington, D.C. My guests were Park Boon-Ubal, TICOM Senior Vice President of Technology and Satellite Operations, Dallas Kasabowski, Analysis Mason Principal Analyst, and John Che, Kratos Vice President. We discussed unleashing the full power of software-defined satellites. Let's join the discussion. Unleashing the full power of software-defined satellites offers operators the potential for a competitive advantage by dynamically adjusting capacity and coverage while in orbit to adapt to customer demand. This opens opportunities to deliver new services, capture more revenue, and enable innovative new business cases for customers. These benefits, however, are not possible without enabling a more dynamic ground system that works in tandem with these new flexible payloads. On this Constellations podcast, you will hear from industry experts from a market, satellite, and ground perspective on how to enable the full power of software-defined satellites and have competitive advantage. So Dallas, I've had you on the air before a couple times, so I'm just jump right in here, you know that. Can you discuss the satellite market and how it's evolving and driving the need for software-defined satellites?
Yeah, thank you. Happy to be here. So software-defined satellites, the easiest way to think about them and where they're coming from, what's driving them, is flexibility. It's just a natural evolution where we've gotten to the point where manufacturing and launching satellites in general is getting easier. There are more options, and players want to have flexibility. They want to have more capabilities. So in some places, and we'll talk about that in future questions, there is real need for these capabilities. And in other places, it's more of a want. I want to stand out. I want to do more. I want to prepare for the markets of tomorrow. And software-defined satellites is just the next step for connecting with the ground and connecting with the changing global market demand.
So John Che, how about you? How do you think this new satellite market is evolving and driving the need for software-defined satellites? Is it going to be all software-defined in the future?
Yeah, and good afternoon. All right, so software-defined satellites is really defined as an investment production. I think most of us would agree in today's satellite market, there's a major disruptions going on. So there's no one, well, including satellite operators, will be able to make a business plan and ensure it will be the same for the next 15 years to sell the capacity that they have planned for. Right, disruptions happening today, disruptions happening tomorrow will change very much the market plans that you have built up to launch the satellite, and that's where software-defined satellites will allow you to really protect the investment, reshape the beams, point it to where the business will drive the revenue in the future.
So, Park, what do you think about software-defined is evolving? I mean, 5-6 years ago, we never mentioned software-defined satellites. It wasn't a thing, and it just came up on us, and suddenly, wasn't it?
Yeah, exactly. Firstly, good afternoon, everyone. Actually, if you look at the basically background of TICOM, we are the regional satellite operators, and we have a total of 8 satellites. All they are fixed satellites, right? We start to procure the next 2 satellites. The first one is we call like semi-flexible satellite, which is TICOM 9. TICOM 10 is fully flexible satellite. So in our definition, maybe continuing from what John said, definitely now today it's difficult to find a concrete requirement for 15 years. So the satellite have to be adaptable for any market demand change. And secondly, that's another benefit of software-defined satellite is that usually you have maybe a bit of technical term, you have a megahertz that convert to megabits, right? That's usually a fixed ratio. I believe if you can manage the market dynamically, technically you can kind of oversubscribe your megahertz. So meaning that the actual throughput, effective throughput of the software-defined satellite is actually higher than the fixed satellite.
So I read the biography of Elon Musk about 3 or 4 months ago, and it sure seems like they're just waves or things happen all at once. And I'm wondering, Dallas, do you think the next wave of software-defined satellites being launched in the next few months, or when it's going to happen?
Yeah, likely in the next few years, next couple of years. Specifically, there are specific orders that have been made for satellites that are expected to come out in 2026, 2027. Mm-hmm. But it also makes sense in terms of the flexibility of the satellites, monitoring, keeping track of, and following the trends on the ground. There's a lot of As I'm sure my colleagues here will talk about, there's a lot of movement being made on the technologies on the ground. But for software-defined satellites, they essentially stalled, right? We saw that, again, as you said, the term came out of nowhere. A lot of technology was being defined, Airbus is OneSat and so on. And then the appeal or the necessity for it became a bit muddled, a bit under question. And now we're starting to see, again, procurement for partially flexible and fully flexible satellites, which we expect to roll out in the next year or two.
So, John Che, do you think it's going to be a whole group of companies launching, software as a service satellites, or just one or two or three or four? So, what do you think is going to happen in the next 4 or 5 years?
Well, so the two big manufacturers of software-defined satellites are really the Airbus and the Thales Group, and they have contracts to deliver these satellites. So, with no further delay, we'll probably see the first launch coming out in 2027. And I will also put a caveat, provided there's no M&A going on this year between them, though.
Well, good luck predicting that, huh? Who knows what's going to happen there?
Yeah.
Don't have an M&A question for you, Park, but when I think of satellites, I think of NGSOs, non-geostationary orbit.
Right.
And so what are the advantages of software-defined satellites when you compare it to something like an NGSO?
I think first of all, what I believe is that there's no one-size-fits-all solutions. So NGSO, they have a lot of advantage, and on the other hand, the GEO satellite also has the unique advantage that the NGSO cannot meet, right? So as a satellite operator, and we start to become a service provider as well. I think we see the trend of putting a base solution to fit to some specific requirement. And some part you need to optimize dynamically between the two. So that's some sort of solution that we are pursuing now.
Yeah, I'll add to that really software-defined technology, in most cases, there's a floor of necessity that non-geo satellites require. They require some flexibility, whether it's steerable beams or reconfigurable bandwidth, just to make the constellation work or to make it work a bit more efficiently. So there's a bit of a floor that pushes them toward partial flexibility. But in GEO, it's becoming all or nothing. There's very few satellites that are looking to be launched that don't have any flexibility at all, but there is a trend toward full flexibility with GEO to work with non-GEO, with or around, really.
So, John Che, is your competition other companies that do software-defined satellites, or is your competition the geostation? So, what's your competition, geostationary orbit or other companies?
Well, I don't think we really put the two in competition. I think, like what Park mentioned, multi-orbit is going to be a common architecture where most countries will adopt. Right, so you need the geostationary, you need the software-defined satellites to provide you the flexibility, the high density that you will get out from these satellites, and coupled with LEO constellations to give you the additional flexibility that grow beyond. Right, and I also like to point out many sovereign countries, many sovereign satellites will still rely very heavily on the geostationary to fulfill their local needs.
So, Park, what are the advantages that a software-defined satellite offers for an operator when competing against the NGSOs?
Competing, maybe not the word I probably try to directly answer, but software-defined satellite from the GEO perspective, and you have the NGSO on the other side. I think in the middle, some sort, if you need to link the two as a one solution, you need a flexible ground, right? That basically can manage the portion or the timing of how to make the software-defined satellite usage in one particular specific scenario, and maybe at another time LEO might be a better option. So that's from the end user perspective. That's the way that you create the best value in terms of users' experience.
So, John Che, imagine you're talking to customers. You're talking about flexibility and what happens if things happen where they dynamically increase the number of data coming through. So in a data center, that's important. And I imagine with you, it's important too.
Definitely. I guess when you start having a flexibility on the satellite that is different from the traditional satellites, right? In the past, you launch a satellite, you leave it up there, you plan the ground. Any new business comes, you manage the ground to meet the business needs. But now with a new software-defined satellite, the payload is flexible. You can reconfigure the beams, the power, where you point to, when you want it to go to. So you will need to have a software-defined ground to match, to provide that dynamic capability to allow you to realize and harness the capability of the software-defined satellite. So this is where I think on the software-defined ground, that's the next topic we're going to talk about, is really on the ground side. You need to be able to be really flexible and dynamic, and virtualization is the key to that. Right? You want as much of the ground to be virtualized as possible so that you can scale. It can be elastic, where you can provide capacity when you need it, and when you don't need it, release the resources for other applications, for other users. So software-defined ground, virtualization will go hand in hand as we talk about harnessing the capabilities of software-defined satellites.
Yesterday we interviewed a couple people. We talked about use cases and business models, and I imagine there's use cases here where you can show how to increase revenue and reduce costs. So, Park, you want to give me an example or increase revenue and reduce costs?
Because of the flexibility, right? So being that you provide the bandwidth to any users at any given time when they need it. So that's a real business case of the software-defined ecosystem. So which one of them, what we would see is that there could be a network of disaster recovery, which means that they might need the bandwidth, huge bandwidth, but they don't need at all the time, right? So you don't need to allocate the bandwidth all the time. So meaning that whenever they need, or whenever we, in terms of prediction, you can just basically provide the bandwidth to that particular area. I think this could play a bigger role in the mobility as well. So which means that mobility, you talk about the large area. In previous, in current today's world, HTS, you're going to need to allocate the capacity in this beam and this beam, so that it's basically fulfill all the part of the mobility. However, with the flexible system, technically you look at the demand, predictively look at the demand, and then you can pre-provision, or that demand can surge up and you can allow the headroom for that demand to grow. So that's some sort of business case that we're looking at the future.
And adding on to that, if you look at the wider ecosystem, not just the satellite itself, but launching the satellite, right? In the traditional model, you would put a geosatellite up. It acts as a flashlight, essentially looking down over a continent. Everything is rigid and defined. But some companies are looking at that and saying, well, instead of raising the amount of capacity that my satellites have to grow with growing trends, if I make my capacity more flexible, maybe I can offer less total capacity per satellite that's more flexible, make the satellite smaller, which may help with launching it, may help with lowering launch prices. There's a lot of interconnected parts between the satellite, the ground, and everything that supports that.
Yeah. John Che, 15 years ago, I interviewed a woman from a virtualization company and VMware, and we had no idea where it was going to go. It was brand new. It was like, well, what's the use case? She didn't know. So what happens is, I guess, you provide something that has all kinds of flexibility, and someone, by golly, is going to figure out what the use case is. I mean, you can't. We're in the early stages of software-defined satellites. I mean, there may be applications that we never dreamed of. Huh?
Exactly. I guess there are many use cases, new business models for us to explore. I think Park mentioned about disaster recovery in the past. If you need certain capacity, a surge in capacity in a particular region, if you don't have the right the amount of bandwidth there, you couldn't support it. You don't have the right amount of gear on the ground, you cannot support it. But with a software-defined ground and a software-defined satellite with a software-defined ground, you can actually meet all this sudden surge in requirements just based on what the customer needs, right? You can put additional capacity, put in additional VSAT resources, fulfill the need, and release those resources back. Another good example is really using data analytics and artificial intelligence to look into the pattern of life of the utilization on the satellite. Right, in the daytime, you will probably have a little higher capacity over a city region. While it goes to the night, it may have gone down, and you channel the capacity and the power to another city that is in the daytime. So you are allowed to now overbook the capacity which Park mentioned earlier, right? 100 gig satellite, you potentially can sell 120. That's a lot of revenue if you can fulfill the full capacity of the satellite by reselling this, moving this capacity dynamically from one region to another region depending on the needs.
Actually, the word is like you oversubscribe the network.
Yeah.
So that the wording I used to talk to the team before.
Yeah, good. Now, Dallas, I know you're not from the United States, and so some things may seem strange to you. There was a company in town called Silo Smashers, and they would go into federal accounts and try to smash the silos, I think it was a noble but futile endeavor. I don't think they succeeded. What about in the satellite world here, Satellite and ground systems have historically been developed in silos. We know that. Are satellite manufacturers and ground system developers now working together to maximize the value of these satellites?
That is happening. There's more conversations that are happening between them. I think currently more present are the operators themselves strategically facilitating those conversations, right? I think manufacturers are being aware of what the ground is doing to some extent. Ground is looking at maybe the capabilities or limitations of the satellite world, but it's still the operators because they have a specific network in mind. They know the customers and the landscape, and they are the ones bridging that connection. But those connections need to happen more and more so that both technologies can develop in tandem rather than in silos.
John Shea, the question is real simple. If you walked around here and you asked someone what a satellite operator was, they'd probably get a kind of an understanding what they kind of do. However, how does the concept of operations change if we're talking about software-defined satellites? Complete different, isn't it?
Yeah, well, definitely. I just want to add on to the previous one. In Kratos, we actually were one of the early adopters or supporters of software-defined satellites. We have been talking to the satellite operators. Our office in Toulouse has been interacting with both Thales and Airbus 3 years before, talking about how we're going to interact and manage the software, the satellite payload, and also the resource management, right? So that interaction is very important to realize a end-to-end connectivity, right? So you need to be able to connect the satellite to the ground, orchestrate all the resources, ensuring all the subsystems operate in synchronized to realize a service, right? To provide a service whenever you need it.
So Park, the whole idea of what a satellite operator is going to change. I mean, it has to. It's going to be managing software instead of managing, I guess, endpoint 3/4 of where around the world. Yeah. So how do you think it's going to change?
The operation with the fixed satellite, you talk about changing the transponder, changing the power. Yeah. You just send the command, right? But for this, I think there's going to be a lot of automation, analytics, and basically intelligence that will basically provide the profile to the network to change. And secondly, the concept of orchestration comes into play now, because you cannot change the satellite, right? Only because terminal connect to the ground segment.
Yeah.
So there will be some system in the middle that basically synchronize the chain between the two, according to the profile or the demand or the predictions. And I believe the operator side, I think from us, we need to look at more on the interconnection with other system. So the proprietary things start to get client blurry now, because every system has to be connected, has to talk to each other, right? So that's how the SDS will work with the ground.
Well, Dallas, the name of this presentation is Unleash Software to Define Satellites with Virtual Ground. So I got to do a virtual ground question here. So how does the ground system need to evolve to maximize the full value of these new flexible payloads?
Yeah, I think John brought it up with the topic of virtualization and digitization. So again, the shape and the design of networks is evolving to be much more flexible in its early design and much more capable and flexible over time. So essentially what needs to happen is the ground needs to get better at orchestrating and coordinating all the different assets that are intended to be connected, but also to look to the future. If you design a network to connect to X number of sites, and you have a clear understanding of exactly how satellite and the ground are going to talk to each other, and maybe it's even flexible to account for them moving or them changing their demand. What happens when you add another 50 sites, 100 sites, whatever that is? So the ground needs to continue in this process of creating a virtualized orchestrated network that can be flexible in its actual requirements, but flexible with new change and new demand.
And Park, there are requirements for security as well in these new dynamic systems. So you have to really put that at the top of the list.
Yeah, you're exactly right? Because of the a lot of more IT automation coming to play with the satellite configuration, which used to be a very private network. Right? So now you connect to outside, you connect to the system. So and given all the advancement of the computing resource now, meaning that cracking the encoding is actually easier than before. So basically what we strengthening is mostly starting with the satellite link, the satellite control link. It's going to be very encrypted and very secure. And the operation and the design of the network orchestration system connected to the ground. We have to look at the security fencings and way there's a lot more to do in this domain.
So Dallas, what new advancements do you need from a ground network to fully harness the minute-by-minute flexibility of satellites? Really, it's dynamically that?
It can be. I mean, if you want to unleash the full power of it, it can be, right? I mean, an example that was given earlier is if you think about like daily or seasonal changes in demand, right? That's not minute to minute. That's where we're getting to now, where demand is changing during the day, you shift your network somewhere else. If you're serving mobility like aircraft or something like that, the demand is shifting. Getting down to minute, really, there are applications that are doing that. We're talking about commodity trading or business or financial interactions. They are millisecond to millisecond. So depending on the application you're looking at, and it's only going to increase. Everything in this market increases in demand, in speed, wanting lower costs. So in terms of what needs to be done, we've kind of touched on it already, but again, orchestration, coordination, automation, just the ability for the system itself to be flexible in its capability and to be able to monitor and react to changes with more automation.
Well, John Shea, he just used the phrase that pays, orchestration.
Yeah.
And I think that's what it boils down to. It's like, when I talk to software developers, they are really herding over several different systems at the same time and orchestrating them. And so that's a skill set that needs, especially with the minute-by-minute changes, huh?
Yep, definitely. So we have, on one hand, you need to have a real-time network management to know exactly what has changed, to have a instant picture of the current network loading situation. You need to have a flexible ground. Virtualization is going to be key to be allowed you to really be dynamic and scalable. The third piece is really to have the orchestration piece, right? To be able to then chain up all these changes, coupled with, of course, data analytics and artificial intelligence to make the necessary changes, to preempt any congestion, to provide additional subscription capabilities on the software-defined satellite. So these are the changes on the ground that we do not see in today's traditional ground systems we have today, where you are pretty much stovepipe, where every VSAT systems will be pushing the limits of what they can do. Every carrier monitoring systems will be doing what they're doing. They are all pretty much stovepipe. And now in the new ground, you need to chain all this together to make them all happen at the same time.
Right, more orchestration, huh?
Yep.
Yeah, that's the phrase. So Park, when you look at resumes for people to hire, are you looking for orchestration now?
No, it's more on the software rather than the hardware. Maybe I want to add a bit on the virtual ground. I mean, okay, we look at the one satellite only, right? Or flexible chain of the beam and many things, right? But with the geo satellite, you can have multiple satellites, right? With multiple orbital slots that can use the same frequency, right? Which means that you technically increase the amount of throughput. And the beauty of the virtual ground is that with the more standard with the telco, so you can create a roaming between the two SDS, two software-defined satellite as well.
Right, flexible.
Yeah, and this is not only within one operator. If we going to a certain standard, it will be a multiple operators. If you look at very long term, I think what we see is that it should be similar to your handset, that you use the SIM card, you can do international roaming, any carrier. So that's probably another step away from after we have the first software-defined satellite launch in the next 2 years.
So Dallas, time to look into the future. I'm not very good at looking into the future. My crystal ball broke back in COVID, so I'm not looking into the future. But I'm asking you. So let's say in the next 5 years, how do you see software-defined satellites and ground systems working together?
Yeah, generally speaking, satellites themselves have been a bit slower to develop. I mean, you can physically on the ground, you can go and update your hardware, you can develop a lot of software, field test it. I think the ground segment has some work to do, but its pace is very quick. Satellites themselves, moving to software-defined satellites now, fully flexible. The future is for satellites to become even more flexible and more capable. So one example of that you'll hear a little bit about is onboard processing, edge computing. Essentially, both of these systems, ground and space, need to work together. And where the work happens is really up to you, the technology you have, the network you've defined. And in some cases, having your satellite have more onboard processing and automation may free up the ability on the ground. Other technologies, regenerative payloads, that's just another fancy term for a more capable satellite. So yeah, briefly, the satellite itself needs to continue to be more flexible and more automated.
So John Che, I asked Park the question about looking for orchestration in resumes, and they have all kinds of different keywords that they search for. So is that going to be the future of this ground system? Is just that going to be someone very, very flexible, understands the engineered systems real well?
Yeah, it's pivoting more to an IT system than a proprietary VSAT and a networking solution. So you really need to build up cloud skill sets. You need to build up virtualization skill sets. Also, I just like to add on to the point on the future. Park was talking about this interoperability. One key topic that's been on the ground this week is really about 5G NTN, right? That will be the next generation of waveforms that will allow us to seamlessly integrate with the MNOs, right? We know the MNOs have much bigger networks. They will enable them to scale a lot faster. A 1 point growth in a terrestrial network is a large growth for the satellite industry. So we want to be able to integrate seamlessly with the MNOs, and the 5G NTN will be the path to allow us to have that seamless integration and allowing the end terminals to be able to roam from one satellite operator to another satellite operator to really unleash the power of all these software-defined satellites.
So Park, we've had all kinds of words kind of tossed around here, and I'm trying to get a prediction for the next 5 years. Do you think it's going to stall, or do you think it's going to be embraced by people because of the added flexibility that software-defined ground gives?
For sure, it's going to be embraced by the people. I believe on-demand is something that everyone needs now, right?
I think we're in pretty good shape. We're running out of time here.
Yeah.
I just wanted to let everyone know that we have a T-shirt here. And free is not a four-letter word. Free, you can go over there, sign up for the podcast, and then get a free T-shirt, and you can be a real space cowboy.